All right, in this lesson, we're going to talk about the characteristics of polynomial functions and their graphs. Don't be intimidated by this format here. This is just a polynomial in general form, but a couple of things to keep in mind. We always write them in standard form, so notice it goes biggest power down to the smallest. The degree of the polynomial we've discussed is always going to be the biggest exponent. The y-intercept of a polynomial is always the constant, and remember, constant is the number without a variable with it. And then just one last thing to keep in mind, the term written in the front, once it's in standard form, this is your leading term, which we can also then find our leading coefficient from, and we're going to need that here in a little while. All right, so we're going to look at a couple parent functions for different polynomials. Some we know and some we don't. So we'll start with quadratic, which we know is y equals x squared. And we know that that is just our parabola, so it looks like this. Our cubic would be y equals x to the third, and we know that that's that snake swiggle looking graph. And then our quartic and our quintic, we don't know, so we're going to see them for the first time here. But quartic would be degree 4, or x to the fourth. It looks a little like the quadratic, but it has a little bit more of a squiggle at the vertex or at the base. And depending on the polynomial, these curves get bigger. A quintic would be x to the fifth. And it looks a little bit like the cubic, but just again, also in the middle, there's a little bit more of a squiggle happening there. Whoa, maybe not that much, but there's definitely more of a squiggle happening right inside of here, okay? And the bigger the polynomial, the more terms, the more squiggle you get right here in the middle. All right, so now let's talk about these particular types of graphs and some of their characteristics. A point where a polynomial switches direction is called a turning point. So if I were to be looking at this graph, I'm going up here, and right here I'm switching the direction to move down, and here I'm switching direction to move back up. These are your turning points. Now, if a turning point is higher than any nearby point, it is called a maximum. If it's lower than a nearby point, then it's called a minimum. Now, polynomials can have multiple maximums and minimums. And so when we look at maximum and min values on polynomials, they are called relative maximums or minimums. And that just means it's relative to the points around it. So it's the highest out of the points that are nearby, or it's the lowest out of the points that are nearby. Could also be called local maximum or local minimum. Now, turning points are basically going to show you where the function is changing from increasing to decreasing. But remember, you never include turning points when we're describing that interval. And so remember, these intervals are always parentheses. All right. So the other thing we're going to look at real quick before we look at an actual graph is the behavior at the end, where the arrows are on the left side and on the right side of a graph. So this is where we're going to need that leading coefficient and degree. And so important to always write your polynomial in standard form so that you get this very quick and easy. All right, so if your leading coefficient is positive, you have two options here. So if your leading coefficient is positive, then you have the degree that could be either even or odd. If you have a positive leading coefficient and an even degree, then that means that your end behavior on the left side is going to go up, and the end behavior on the right side is also going to go up. Now, the way that we describe that, we can say rise for up, but the way we describe that in algebra is we say as x approaches, and if we're talking about the left-hand side, we're going left forever, so we're going to say as x approaches negative infinity, and that's just saying left side, the y value approaches positive infinity because it's going to point up. If on the right-hand side, I'm going to say as x approaches positive infinity, because the x-axis moving to the right forever goes to the positive infinity, but the y values would go also up. So now the y values we're describing as also going up to positive infinity. So we could say the left side rises, the right side rises, but this is how we would say it using the algebra. If my leading coefficient is negative and even, that means that on the left side it's going to move down, and on the right side it's also going to point down. So notice that if it's an even degree, they either both point up or they both point down. So on the left side we would say as x approaches negative infinity, the y values also approach negative infinity. In other words, as I move to the left, the y values or the graph is pointing down. For the right side, we're going to say as the x's go to positive infinity, because I'm moving to the right, the y values are going to negative infinity. So here we would say it falls on the left and it falls on the right. Now, if my leading coefficient is positive and odd, the odd degrees don't go the same directions, they go different directions. And so we got to be careful on this one. On the left side, it would fall. On the right side, it would rise. So we would say as x approaches negative infinity, the y values go to negative infinity. On the right side, as x approaches positive infinity, the y values approach, because we're going up, also positive infinity. So they go in opposite directions. So if you have a positive leading coefficient and odd, you're going to have a fall, then a rise. If it's a negative leading coefficient with an odd degree, it does the opposite. So on the left side, it rises, and on the right side, it falls. So as x approaches negative infinity, since we're going left, the y values go up to positive infinity. As x approaches positive infinity to the right, the y values approach negative infinity because it's pointing down. So here, this one would say rise and then fall. Now, as we do more practice problems, this makes a little more sense. I know it's a lot kind of all at once, but let's do some examples so that you can see this guy in action with graphs. All right, so I've got several different polynomials here. First and foremost, make sure they're in standard form. Then we're going to give the degree, and we're going to tell if it's even or odd. Give the leading coefficient, and then decide or show whether it's positive or negative, and then kind of sketch the end behavior with arrows so that you can see. All right, so first, number one, it's in standard form. The y-intercept, remember, is your constant. So my y-intercept is 31. The degree is the largest degree, and if you've put this in order, should be with your leading term. So the degree is 2, which means we've got an even degree. The leading coefficient would be this constant or number in front of the x. So my leading coefficient is 12, which means it's positive. So if I have an even degree, that means my end behavior should point the same direction. And if it's positive, that means they both should point up. So here we would say rise, rise. And here for now, we'll just do a quick sketch so that you can see it. On the next one, again, it's in order. The y-intercept would be negative 18. The degree would be 4, which again is even. The leading coefficient is -3, which means we're dealing with a negative leading coefficient. And remember, if it's even, they point the same direction. If they're positive, they both point up. If they're negative, they both point down. So this one would be fall, fall. The next one, again, double check it's in standard form. Your y-intercept is -2. Your degree, the largest degree is 5. In this case would be odd. And your leading coefficient is 9, which is positive. Now, if you have an odd degree, they go in different directions. If it's positive, it would be fall on the left, rise on the right. Number 4, the constant here is not written, so remember that means your y-intercept or your constant is 0. Your degree is 7, which is odd, and your leading coefficient is a -1, which makes it a negative number. Now, if it's an odd degree and a negative leading coefficient, they point in opposite directions, but it goes this time rise and then fall. All right, so now let's actually look at a graph and look at their end behavior from the graph and then determine what its degree is, even or odd, and then decide if our leading coefficient is positive or negative. All right, so in behavior, it's what the arrows are doing on the left and on the right. So on the left, this is falling. On the right, it's falling. So if we have fall on the left and fall on the right, that means we're working with an even degree and a negative leading coefficient. And I'm going to write LC for leading coefficient. On number 6, on the left, we have fall, and on the right, we have rise. So in this case, because they're going in opposite directions, I know it's odd degree. But because it's fall then rise, that tells me that we had a positive leading coefficient. All right, so here's a couple of examples. And we're going to do everything, and then we're also going to read our graph using our minimums, maximums, and identifying our increasing and decreasing intervals. So first, let's talk good old domain and range from back before our semester break. Remember, domain is left to right. These arrows go forever, so our domain in this case would be all real numbers. Our range points up forever, but it does not point down forever. The lowest that this graph goes is -6. So our range goes from -6 to positive infinity. Bracket, parenthesis, because any point on this graph is a solid circle. You could have also said y's that are greater than or equal to -6. Now, relative maximums. These would be high points in the surrounding area of certain points. So this is considered a high point, and this is considered a high point. So you have two relative maximums at -4, 0. Actually, let me take that back. You have two relative maximums at -4, 0 and -1, 7, but these are y values. So keep in mind, anytime you're giving a min or a max, you're always just telling the y value. So we have two. We have a y value that's at a max when we're at 0 right here, and we have a y value at 7. And so those are your relative max values. Your relative min is the points that are lowest in an area. So this is a low point and this is a low point. So we have two of them. Again, we're talking y values. So the relative minimum y value was -6 and 0. Oh, time out. We have one more here. So let's put them in order. We have -6, -2, and then 0. All right, so using our turning points, now we look to see where is this graph increasing and where is this graph decreasing. Keep in mind that when we do intervals of increase or decrease, we're looking at the x values. So as we look at our turning points, and I'm going to label them here, those minimums and those maximums, where is my graph increasing? So that is where my graph would be moving up from left to right. So we've got an increase here, we have an increase here, and then we have an increase here. So when we write this interval, we're going to use unions. Remember, x values from -5 to -4, it was an increase. And remember, we never use turning points. Union from -2 to 1, we had an increase. Union from 3 to infinity, we also showed an increase. All right, so now let's do our decreasing, and I'm going to go ahead and switch colors for that. Our decreasing is when the graph is going down from left to right. So here's a decrease, here's a decrease, and then here's another decrease. Again, writing in intervals would be from -infinity to -5, and again, we're using x values here, from -4 to -2, union, and then we had one more from 1 to 3. Okay, and so keep in mind when we do these are x values. All right, and so now let's do the new part, our end behavior. So what is happening at the end behavior? So on the left side, we are rising. On the right side, we are also rising. So as x goes to -infinity, this means the left side. What is the y value doing? Well, because we're rising, that means the y value is going to positive infinity. As x approaches positive infinity, that means we're moving to the right. Now we're looking right side. The y values are also rising or going to positive infinity. All right, let's do one more. And then you're going to try some of these on your own. All right, so in this next graph, domain again is going to be all real numbers. So the range in this case has an arrow that points down forever and an arrow that points up forever. So this also would be all real numbers. Relative maximums, the tops, so there's a maximum and there's a maximum. So the maximum values are the y's, so 2 and 4, and squiggle brackets because we're listing them all. The minimums would be the lows. So here's a low and here's a low. So we have 2 of them, and remember, you're listing the y value. Okay, and again, let's write it off here. These are y values. Increasing and decreasing. So when is my graph moving up from left to right? So looking at my graph, we go up right here, we go up right here. So there's 2 places. And again, these are x values when we describe it. It goes from -6 to -3. Never include them, so parentheses, union, 0 to 4. Decreasing, when we go down from left to right, so there's a decrease, there's a decrease, and there's a decrease. This time we have 3. And again, x values, -infinity to -6, union, -3 to 0, union, 4 to positive infinity, because we're looking at the x value, not the y. So x is moving to the right forever here. And again, keep in mind these were x values when we listed them. All right, our end behavior is what's happening at the very ends. So in my particular graph, on the right side, it is rising. On the left side, it is falling, which tells me, oh, and we didn't do that on the other one. We'll go back. This tells me the degree has to be odd because they're going in different directions, and leading coefficient is negative because it's rise and then fall. So as x goes to negative infinity, the left side, the y values of the graph are going up to positive infinity. As the x values go to the positive infinity side, that means the right side, the y values of the graph are going down to, negative infinity. Now, we didn't answer this one, degree, so let's go back. We had a rise here, so that tells me the degree is even since they're pointing in the same direction. And the leading coefficient is positive because they're both pointing up. All right, so you can go back and rewatch this if you need to, but now go ahead and try the assignment. It is in Delta Math. There isn't really much work to do, so this Delta Math does not require work on paper.